Alrighty then. Geometry 2.3, postulates and diagrams. Okay, we are going to be using this page, page 84, these postulates that you're going to put into your notes. Oh man, there's a lot of stuff in your notes. So, this one states, 2-point postulate. Here's a line. Through any 2 points, there exists exactly one line. So, here's 2 points. And the line that goes through these 2 points is the one that right there. So, you can say, well, Mr. Trump, look at this. There's another line right there. There's more than one line that goes through those 2 points. No, because a line is considered to be straight. Line is derived from linear. Linear and line, they're related to each other. Linear means straight, so line refers to a straight line. This right here would be considered a curved line. It's a curved line, okay? Line point postulate, line contains at least 2 points. So any line you want, here's a line, and if you're gonna name this line, you either give it line G or line H or line L or line M, or if it has points, you need at least 2 points. Let's say P and let's say T. Okay, line PT or line TP. Line intersection postulate states that if lines intersect, then their intersection is exactly 1 point. In this case, it'd be point C. 3-point postulate, through any 3 non-collinear points, there exists exactly one plane. So here's points D, E, and F. And there exists only one plane that goes through those 3 points, and in this case, it's plane R. This one right here, 2.5, says the plane point postulate. A plane contains at least 3 non-collinear points. So these are vice versa. Through any 3 points, through any 3 non-collinear points, there exists exactly one plane. Do the converse. A plane contains at least 3 non-collinear points. If it's a plane, then it contains at least 3 non-collinear points. Plane line postulate. If 2 lines line a plane, so 2 points, if 2 points line a plane, then the plane containing them lies in the plane. So if you have a plane, and let's call this, if 2 points line a plane, here's a point, then the line containing them lies in the plane. So the line that goes through those 2 points would also have to be in this plane. Okay, so points D and F, if you draw a line between point D and F, going through points D and F, then that line would also be considered in the plane R. Plane intersection postulate. If 2 planes intersect, then their intersection is a line. So here's 2 planes intersect, plane S and plane T, and their intersection is line L. Not Lionel, but line L. Ka-ching. Okay. Here, state the postulate illustrated by the diagram. You are going to be going back to this page a lot and referring to the stuff on page 84 a lot. And never identify this as, oh, it's postulate 2.3, because I have no idea what 2.3 is. I've seen a bunch of different books, and 2.3 in this book may be something completely different in a different book. So never refer to it as postulate 2.3. You may refer to it as the line intersection postulate. So here, state the postulate illustrated by the diagram. If bleh, then bleh. Here's 2 lines that intersect, then the intersection is exactly 1 point. Right there. If 2 lines intersect, then their intersection is exactly 1 point. It's the line intersection postulate. Okay? So this next one. Here's 2 planes intersect, and here's a planes intersect, and there's a line. When 2 planes intersect, their intersection is a line. Happens to be this one right here, which is the plane intersection postulate. Flip the page. This is page 87. So on this one right here, and let's get this down so we can read it. There we go. In exercises 3 and 4, state the postulate illustrated by the diagram. Here's 2 points. If you have 2 points, then you could draw a line between those 2 points. I wonder what that would be. Through any 2 points, there exists exactly one line. I wonder what postulate that would be. Number 3. It's the 2-point postulate. Okay. Excuse me. We'll just try it. There we go. I can read it. Use the diagram to write an example of the postulate. So we're going to use this diagram. And number 5 says line point postulate. Okay, line point postulate, which just happens to be 2.2. So 2.2 states a line contains at least 2 points. A line contains at least 2 points. So in this diagram, we want to find a line that contains at least 2 points. You can say line P contains points H and G. You can say line Q contains points J and K. There's a lot of different versions you can use for number 5. Line Q contains J and H. Line Q contains H and K. Line Q contains J and K. JK. Okay. Next one, sketch a diagram of the description. Plane P and line M intersecting plane P at a 90-degree angle. So, zoom out for this, buddy. So, they're saying, here's a plane. And let's call it plane P. Sorry. Rank plane P. Let me get this so we can read it. There we go. Plane P. This is going to be called plane P. That's plane P. And line M intersecting plane P at a 90-degree angle. So you cannot stick it this way because this line right here is on plane P. So basically what we're doing is we're saying the line goes right straight through. Something like here's plane P and it goes right to that point. We need to give me an example like this where this is a 90-degree angle. Okay. So that's a 90-degree angle. That's 90 degrees, but this would not be considered a 90-degree angle. So you need to make it 90 degrees. How do you draw that? You do this, you go, it intersects right here at plane. So we just need to make an intersection. It's going to go through there and continue on that way. So we have something like this. Here's a point, the intersection point P. So this is called line M. Line M, it's lowercase. Plane P at 90-degree angle. So we've made a 90-degree angle. So I'm going to put a little box or a little elbow there, 90 degrees, and it intersects right at that point. This would be an example for number 9. Okay, there's the example for number 9. One example. Next, number 13. Question 13. Question, earthquake, stop that rocking. Use a diagram to determine whether you can assume the statement. Can we assume that planes W and X, plane W and plane X, intersect at line KL? Plane X is this plane. Plane W, there's W, this plane W. So these two lines intersect, these two planes intersect right there. There's a line right there. And that line, could you call it line KL? Contains K and L. Yes, yes, you can assume that statement. Yes, that'd be true. Yes, you can make that assumption. Yes, you can make that conclusion. Okay. There we go. Good luck, guys. You will be referring a lot to this material here on page 84. A lot of stuff you're going to be going back to on page 84. Okay. Bye, guys.